This is the final section for 9.4 partial fractions. So this one is basically where if you started off with a denominator like x to the fourth plus 2x squared plus 1. If this was your denominator instead of what I have here, and you were wanting to break this down and do the partial fraction decomposition, the first thing you'd have to do is factor it. And if you factor this, you could factor it into x squared plus 1 times x squared plus 1. But the problem is, those are not factorable. They're quadratic, so it's x squared, and then but it's a part of a binomial, it's not factorable. And not only that, but it's the same factor repeated. So it's similar to what we did in the last problem, but now it's also similar to a previous one where you have the same factor being repeated. So, since I have two factors, I do have to break this down into two fractions. But I can't just do x squared plus 1, x squared plus 1. Because then they'd already have a common denominator. And there has to be a reason why it ended up with this denominator of x to the fourth plus 2x squared plus 1. So this is to the second power. So the first one is going to be to the first power, and then the second one has to be squared. So again, if this was to the third power, I'd have three factors, and I'd have this one to the first, this one to the second, and the third one would be to the third power, and so forth. Because they're quadratic, also, they will have an x in the numerator. So you've got to have something x plus something. Something x plus something. That's the way the numerators look when you have a quadratic factor for the denominator. So we just need to fill those in with letters that we're needing to find. So ax plus b, and then cx plus d. You can call them whatever you want. All right, but typically this is the way you see it. You just go alphabetically. So those are the four things I need to find. I need to find a, b, c, and d. So that's the first part. That's the setup. Once you have it set up, you're then going to go about this the same way I've done for every other problem. I don't want to have this denominator here. So I'm going to multiply by it. So I'm going to multiply by x squared plus 1 squared. And I'm going to do that here. I'm going to do that here. And I'm going to do that here. So you have to do it in every single term. Now what that allows me to do is these two factors down here cancel out with both of those. So all I have left on the left side is 3x cubed minus x squared plus 5x plus 1. On this side, I have a single, and I know I put a 1 there, you didn't have to put that there, but x squared plus 1, I have a single factor of that here. So it doesn't cancel out both of them, it only cancels out one of them. So I still have ax plus b times x squared plus 1. Here, it cancels out with both of those factors. So I'm left with cx plus d. So that's the key second step. Whatever this denominator is, that's what you're going to multiply everything by. It'll cancel out this denominator completely, and it'll cancel out one of these completely, but not every single one of them. So now I want to use the technique that I did in the last video. I want to simplify this right side as much as I can and leave this the way it is, 3x cubed minus x squared plus 5x plus 1. But I need to simplify this side. So I've got to take this expression and I've got to simplify it. So that's a binomial times a binomial. So I need to FOIL. So first terms, ax times x squared would be ax cubed. Ax times 1 would be ax. B times x squared would be bx squared. B times 1 would be b. And then I still have this plus cx plus d. So that looks like a huge mess. But I only have one cubic term, so that's the ax cubed. I only have one x squared term, so that's the bx squared. But notice I have ax and cx. Those both have an x, so I want to combine them together. So that's going to be a plus c as my coefficient of x. Everything that's left over, the b and the d, those don't have a variable with them. So those together make up the constant. It'd be like if I had a 5 and a 7, I'd add them together to be 12, to be my constant at the end. I just don't know what they are, but that's my constant. So on this side, I have 3x cubed minus 1x squared plus 5x plus 1. But now I'm looking at, here I've got a, 3, and a that correspond with each other. So that immediately tells me a is 3. Okay, so that part, that's pretty simple. Move on to the next one. I've got a -1 in front of the x squared. Here I've got a b. So I know that b is -1. So far it's been pretty simple. Things get a little more complicated after that. Here I've got a 5, and here I've got a plus c. So a plus c equals 5. But I know that a is 3. So 3 plus c equals 5. That means c has got to be equal to 2. So I've got a, I've got b, I've got c. Moving on to the constant, I have b plus d is equal to this 1. But I already know b. b is -1. So -1 plus d is equal to 1, so d is equal to 2. So there's my fourth and final value. Now, this system is pretty simple, but you may get times where you might get a system that has two equations where it might be a plus b, and that might be a minus b, or something like that, where you have two different variables, and you might have to solve it using the substitution method or the elimination method. Something like that. Or when they get really, really complicated, it's possible you might end up with an equation with 3 variables in it. You might have to do something like the row echelon form thing that we did. It just all depends on the problem. But now we've gotten to our values here. So it goes back to the original equation was this. It's just me doing the same stuff that I just worked out for you. But here's what I was originally solving for. That's right here. Now, this part has been rewritten with the a, the b, the c, and the d in there. And this is my final answer, where I've taken this and I've broken it apart into 2 fractions.